Alright, let's look at another property of Laplace transform. So suppose that the Laplace transform of f of t, which you know this is its definition, and let me just call that to be f of s. Well, let's figure out the Laplace transform of f of at. In other words, I'm just going to plug in at into this t right here. And I want to just make this simple in this video. I want to say a is a positive number right here. Even though this formula will work for any non-zero a, right? But let me just say a is greater than 0, and if a is negative, you will just do it on your own, and then the formula is the same at the end anyway. All right, so now let's see how we can do this. Ideally, I want to come with a formula in terms of s in the s world, f of s right here, and then let's see how we can work it out. The best bet is let's just go ahead and use the definition right here, right? So let me put it down. The Laplace transform of f of at. This right here, by definition, I will have to plug in f of at into this, right? So it will be the Laplace, the integral from 0 to infinity, e to the negative st times that, which is f of at. And don't say this is fat, this is f of at. Anyway, dt, like this, right? And what can we do next? Well, I'm going to utilize u-substitution. Because as long as you see the input are the same, I will get f of whatever this s, not s. This input right here is at, which is not the same as this t. So this is what we can do. U-substitution in action. And I'll put it down right here, that u equal at, and I will say du, which is going to be a dt, and of course I can divide by a on both sides, so we get dt equal to du over a, all right? So this is what we have, and now, do it carefully. 0 to infinity, it's in terms of t, right? So let me just emphasize that this is t goes from 0 to infinity. And now, as usual, we'll take this integral into the u world. Well, here is that part. That's why I will say a is greater than 0. When t is equal to 0, plug into here. Yes, u will be a times 0, so of course, u will be going from 0, for sure. But when t is infinity, plug into here. You have two choices depending on a. If a is negative, you really have to put down negative infinity. But as I said, in this video, I just want to show you the case when a is greater than 0. So when t is infinity, plug into here, positive a times positive infinity, u will also go to positive infinity, all right? U will be going to infinity as well. If you have the negative infinity here, you just have to switch the integral around, the limit around, and then the negative signs are wrong and things like that. But now let me just focus on this. I'll come up with a nice formula for you guys, so just watch. All right, so this is what we have at the moment. And now, we still have e to the negative st, but I will keep the negative as negative because for the st, I would like to change it a little bit. Look at this right here. I will put on the s first though. When we know u is equal to at, because I need to change this integral into the u world, right? T has to be changed into t equals to u over a, right? So this t becomes u over a like that, okay? And now f of at, I think I'll just do this in blue right here. F of at becomes f of at, which is the u. That's what we have. And then dt, which is du over a. So this is du over a. And I should put this down in blue as well. So du over a. This is what we have. Very good. And now, what can we do next? In fact, we are almost done. This is what you have to do. The exponent here, I will put the s and the a together. And then this is 1 over a, right? That's a constant multiple, so I'll bring that outside. So you will see this is equal to, let me bring the constant multiple 1 over a on the outside, and then we have the integral from 0 to infinity in terms of u. And then this is going to be e, and I will write this down as negative s over a, and then u right here. And this is still f of u, and then du. All right? Okay, this is still 1 over a, no problem at all. But as you can see from the original right here, the reason that this is f of s, it's because right here you have negative s and then t. So it's because of this s here, right? This is your input on the left-hand side, according to how we have. And you just plug in the same exact input, which is this s right here, right? And now, if you just mix and match, look at this. The input is s over a, right? Because you see the negative match. Even though this is t, but here we're using u. However, the rest match, u, du, t, dt. So this is what we call the dummy variable in terms of integral. As long as the limit and then the other form match, we can say that this right here is just f of the new input, which is s over a. Once again, you plug in this into here, and that's it. This is the result when we have the Laplace transform of f of a t. That's it.